Welcome to this session on algorithms, where we'll be looking at the breadth first search algorithm. When exploring or traversing a graph, there are two main algorithms that are used to traverse graphs. There's the breadth first search algorithm and there's the depth first search algorithm. We'll specifically be looking at the breadth first search algorithm in this session. So the depth first search algorithm is what is known as a recursive algorithm. This is an algorithm that calls itself. The depth first search algorithm is an algorithm that goes as far down the graph, a path in the graph, as possible, and then backtracks to then go down another path and go as far down that path as it can before again backtracking and then doing the same to another path in the graph. And therefore it's referred to as a recursive algorithm. The breadth first search algorithm in comparison is referred to as an iterative algorithm. Now, this refers to iterative algorithms are algorithms where there is a procedure that is repeated multiple times. In the breadth first search algorithm, a given node such as node A, the algorithm explores or traverses all the adjacent nodes. So we use the word adjacent, all the adjacent or neighboring nodes of node A. So we can take a look at that. And then once all the adjacent nodes of node A have been visited, the breadth first search algorithm will then move on to node B and will explore all the adjacent nodes of node B. And then so on and so forth. So the breadth first search algorithm is an algorithm which referred to as iterative, and the depth first search algorithm is an algorithm that's referred to as recursive. Again, as I said before, this session will be focused on the breadth first search algorithm. So let's look a bit more at the breadth first search algorithm and how it is applied. So as we've said, the breadth first search algorithm works by exploring all the neighbors of the current vertex, then the neighbors of each of those vertices, and so on and so forth. Now with the breadth first search algorithm, all the nodes adjacent to A are visited before moving on to B, and then the process is repeated for each node at this level before moving to the next level. So here we go, here we are. We have a given graph. So we've got a graph N here, and we're going to apply the breadth first search algorithm to graph N. Now to apply the breadth first search algorithm, you'll need a list, and the list will record all nodes that have been visited. You'll also need a queue. And the queue is there. Its purpose is to hold all nodes that are yet to be visited. So the list records all nodes that have been visited. And the queue will hold all nodes that are yet to be visited. So let's have a go at applying the breadth first search algorithm to this graph. So we'll start off with node A. So we'll visit node A. Here we are. And as we've said, the breadth first search algorithm will explore all nodes adjacent to node A. So we have node B, node D, and node E. So now that we've visited the node A, we can pop node A from the queue and place and record node A has been visited in the list. Next, we move on to node B. Node B has node D held in the queue, but it's also adjacent to node C. So we need to record or hold node C, place node C in the queue. Now that we've identified all nodes adjacent to node B, we can then pop node B from the queue and place node B in the list. Next, we go to node D. Node D is adjacent to node E and node F. Node E is already held in the queue, but now we can insert node F in the queue as well. Now that we've visited node D, we can pop node D from the queue and place node D in the list as visited. Moving on to node E. Node E has been visited and all its adjacent nodes are now or have already been visited as well. So we can pop node E from the queue and place node E in the list. Moving on to node C. Node C is adjacent to node B, which has already been visited, and it's also adjacent to node G, which has not yet been visited, so we can place node G in the queue. We can record node C as being visited and pop node C from the queue and place node C in the list. Next, we will visit node F. Node F is adjacent to node D, which has already been visited. So we can pop node F from the queue and place node F in the list. Finally, we visit node G. Node G is adjacent to node C, which has already been visited. So we can now pop node G from the queue and place node G in the list as having been visited. And that now leaves us with this iteration of visited nodes. Now, that is how one would the logical application of the breadth first search algorithm in of a graph. Now, to see this in coded, we can take a look at how this might look like in code. And there we go. Now, taking this program, it's taken from Edpresso, and that's www.educative.io. Edpresso, how to implement a breadth first search in Python, was taken from, so this program which is written in Python, was taken from this website, and it's an example or an exemplar of a breadth first search algorithm written in Python. If we take a look at the code, so here I have I've opened my PyCharm, Integrated Development Learning Environment PyCharm, and I have the implementation of the breadth first search algorithm in Python. Line 1 to 9 sees the graph represented using the dictionary data structure, where each vertex has a list of adjacent nodes. So you've got the dictionary with each vertex, and each vertex whole has a list that show its adjacent nodes. Line 11 shows a list called visited, and visited is a list that is used to keep track of visited nodes. Line 12 also has a list called queue, and queue is a list used to keep track of nodes currently in the queue. Going further down into this implementation, we see a function called BFS, which has the following arguments. It's got the list, it's passed the list called visited, the graph dictionary, and it also receives a node as its third parameter. Now, the function BFS basically checks and appends the starting node to the visited list and the queue. Then, while the queue contains elements, it keeps taking out nodes from the queue, appends the neighbors of that node to the queue if they are unvisited, and then marks them as visited. This continues, of course, until the queue is empty. So if we run this program, we can run it here and then see it execute. And there we go. I have edited this graph to mimic the graph we traversed earlier, and you can see that the output is the same output that we received earlier. So moving on, from this implementation of the breadth first search algorithm, we can look at applications of the breadth first search algorithm. And applications include finding the shortest path between 2 points, using a web crawler to analyze sites that you can reach by following random links. And Facebook actually uses the breadth first search algorithm to find or identify all your friends and contacts. So to wrap up, that's the breadth first search algorithm. We've looked at how it works, its applications, and we've seen an example of how to apply the breadth first search algorithm to the traversal of a graph.